All right, let's get right into it. We are about to uncover the single most important idea in all of plate tectonics. And I mean it. Once you get this one idea, everything else just clicks into place.
You know, we all hear it. It's the one thing everyone learns about geology in school. Continents move. They drift around. Seems pretty straightforward, doesn't it?
But what if that simple statement, the one we all think we know, is actually hiding the real story?
That's right. As a core concept, it's just wrong. Continents don't really do anything on their own. They're just passengers.
Because the real action, the thing that's actually happening, is that the massive, rigid tectonic plates are the ones in motion.
And this right here is the absolute key. If you understand this one sentence, you understand the engine that drives earthquakes, builds mountains, and shapes our entire world. They don't slide, they rotate.
Okay, to really get this, I want you to do me a favor. Forget all those diagrams you've seen with arrows and conveyor belts. Just clear your mind. Let's build this whole thing from the ground up, starting from zero.
So let's start with just four basic, undeniable facts. 1. The Earth is a sphere. Got it. 2. Its surface isn't solid. It's cracked into a bunch of huge pieces. 3. These pieces, these plates, are rigid. They don't stretch or get squishy. And 4, when a plate moves, the whole thing moves together as one solid unit.
And here's the perfect way to picture it. Imagine a hard-boiled egg that you've gently cracked all over, but you haven't peeled it yet. Each one of those little fragments of shell is like a tectonic plate. It's a solid, rigid piece on a curved surface. So, this brings us right to the heart of the matter. We have a rigid object on a sphere. And this is where it stops being about geology for a second and becomes a pure geometry problem.
Let's really think about that for a second. If you have that solid, unbending piece of eggshell, how can it possibly move across the curved surface of the egg without shattering or deforming?
Well, it can't just slide in a straight line. That works when you slide a book across a flat table, but on a sphere, the curve itself gets in the way. So there's only one possible way for that rigid piece to move across the surface. It has to rotate. Just think of a door swinging on its hinge. That's it. That is the only motion that works.
Now, any object that rotates has an axis. For a tectonic plate, that axis runs right through the center of the Earth. The point where that invisible axis pops out of the surface has a technical name. It's called an Euler pole. But don't worry about the name. Just imagine that every single plate is spinning around one of these fixed pivot points on the globe. So what happens when we start looking at the planet with this idea in mind? Well, once you accept that all plates rotate, a whole lot of geological mysteries just stop being mysteries. They become simple, obvious consequences of geometry. And this is exactly why all those maps you see in textbooks, with the little straight arrows showing how plates move, well, they can be really misleading. They're not completely wrong, but they're a simplification that kind of hides the beautiful truth of what's going on. It really is just a matter of perspective. Locally, if you're standing in one spot, the Earth looks flat, and so the plate's motion looks like it's in a straight line. But as soon as you zoom out and see the whole globe, you see the Earth is a sphere, and that means the motion must follow a curved path. It's an arc of rotation around that plate's specific pivot point. And wow, this changes how you see everything. Take the Mid-Atlantic Ridge. We tend to think of it as this giant engine pushing the continents apart, but it's not the cause. The cause is that the South American and African plates are rotating away from each other. The ridge is just the seam. It's the gap where new crust fills in as they move apart. It's an effect, not a cause. And what about things like the San Andreas Fault? These aren't just random cracks. Think about it. If a huge rigid plate is rotating, the parts farther from the pivot point have to move faster than the parts closer to it. The plate has to break along these curved lines to accommodate that difference in speed. They are a geometric necessity. If plates rotate, transform faults must exist. So here's the bottom line. This isn't just a cool thought experiment. This model of rigid plates rotating on a sphere is so powerful because it actually works. It makes predictions that we can go out and test in the real world. And the evidence is just overwhelming. We have incredibly precise GPS stations all over the planet, and we can literally watch the plates rotating in real time. And guess what? They match the predictions perfectly. The patterns of earthquakes all over the globe, they light up the exact boundaries of these plates, just like the theory says they should. It all just fits. So I really want you to leave with this new picture in your head. Throw away that old idea of continents just floating around like boats on the ocean. Instead, picture our world as a sphere covered in a few massive, rigid shells, and each one is rotating in a slow, majestic, and perfectly predictable dance. When you start seeing the Earth this way, as a system governed by the simple geometry of rotation, everything from the deepest ocean trenches to the highest mountain ranges begins to make perfect, logical sense. So the question is, what else can you now explain?